What's up, everyone? Today, we are going to be evaluating all 6 trig functions. It's going to be a good time. I think you guys are going to like it and feel real smart by the end of it because you're little baby geniuses. So grab a piece of paper, grab something to write with, and a calculator, and let's hop into it. Oops, just kidding. Let me grab the mouse. My bad. Okay, so your warm-up or do now is to fill in the blanks for each angle family. We're talking about reference angles 30 degrees, 45 degrees, and 60 degrees. I want to know what are the radian measures in all 4 quadrants, and then what are the coordinates from our unit circle, from our reference angles, that will help us to fill in all of the blanks. So go ahead, take a second, and fill them in for theta is equal to 30 degrees. Okay, so theta is equal to 30 degrees is pi over 6 measurements. So looking at our quadrants, right? In quadrant 1, 30 degrees is going to be right down here. That's a little messy, but we've got pi over 6. So all of our 30-degree measures are in increments of pi over 6. So I basically can count out all of the values of pi over 6, and if they are reducible, that is not the values of pi over 6 I want. I want the values that are not reducible because otherwise those are going to end up as pi over 3 radians. So in quadrant 1, I have pi over 6. Then I have 2 pi over 6, which reduces to pi over 3. Then I have 3 pi over 6, which reduces to pi over 2. Then we have 4 pi over 6, which reduces to 2 pi over 3. And then we finally have 5 pi over 6, and that guy is in quadrant 2. 6 pi over 6 is just pi. 7 pi over 6 is in quadrant 3. 8 pi over 6 is reducible. 9 pi over 6 is reducible. 10 pi over 6 is reducible. And lastly, 11 pi over 6 is the value in quadrant 4. Now, the coordinates that are associated with 30 degrees, we can use our trusty unit circle song. Remember, the quadrantal points start at 1, 0, root 3 over 2, 1/2. That is the value of our coordinates for 30-degree angles as we're making our way around the unit circle. So root 3 over 2, 1/2. Let's do the same for angle measures of 45 degrees. Give it a go, and I'll be right back. Okay, so 45 degrees is right smack dab in the middle. And since the value up here is pi over 2, halfway between that, well, that's pi over 4. So everything that's a 45-degree angle in every quadrant is always going to have 4 in the denominator. So in quadrant 1, that is 1 pi over 4. 2 pi over 4 reduces. 3 pi over 4 is in quadrant 3. 4 pi over 4 reduces to just pi. 5 pi over 4 is our radian measure in quadrant 3. 6 pi over 4 reduces, but lastly, 7 pi over 4 is our radian value in quadrant 4. Again, using our unit circle song, we start off at 1, 0, root 3 over 2, 1/2. Root 2 over 2, root 2 over 2, and the rest is just a laugh. So our coordinates are root 2 over 2, root 2 over 2. Pi over 4 and 45 degrees are the ones that deal with 4s, and also root 2s over 2s. They're identical all the way. Lastly, let's do angle measure 60 degrees. What are the associated units for quadrants 1, 2, 3, and 4? All right, so in quadrant 1, this is going to be pi over 3. Pi over 3. It's 2 pi over 6, which reduces to pi over 3. So continuing the pattern, we have 1 pi over 3. Then we have 2 pi over 3 in quadrant 2. 3 pi over 3 is just pi. 4 pi over 3 is in quadrant 3, and then 5 pi over 3 is in quadrant 4. 6 pi over 3 ends our unit circle and brings us back to 2 pi. And again, following the unit circle song, root 2 over 2, root 2 over 2, and the rest is just a laugh. 1/2 root 3 over 2, 0, 1, you're done. You can find the rest of the coordinates if you just know quadrant 1, right? And just a little quick refresher, in quadrant 1, x is positive and so is y. In quadrant 2, x is negative, but y is positive. In quadrant 3, x and y are negative. And in quadrant 4, x is positive, but y is, y is negative. Cool. So now that we have reviewed some things, I want us to evaluate trig functions. So we have 3 trig functions, sine, cosine, and tangent, and I want you to evaluate them. Tell me the exact value. Do not use a calculator. Use your unit circle to figure out what is sine of 5 pi over 6, what is cosine of 5 pi over 6, and what is tangent of 5 pi over 6. To guide your learning here, ask yourself, which quadrant is this angle measure 5 pi over 6 located in? What are the signs for that quadrant? What are the coordinates of things that end in pi over 6? And then which variables represent sine and which variables represent cosine? So take a second and grab your mind, your unit circle, and evaluate sine, cosine, and tangent of 5 pi over 6. Okay, so 5 pi over 6 is located in quadrant 2, and the signs for x and y in quadrant 2 is x is negative, but y is positive. So the xy coordinates for anything ending in pi over 6, including 5 pi over 6, you can see I've drawn it in the top right-hand corner over here, is 1/2 root 3 over 2. Okay, so we're going to use that information, 1/2 root 3 over 2. That are the coordinates for it, but in quadrant 2, x is negative. So these are the coordinates I'm going to be using. And remember that cosine is x and sine is y. Sine is y, cosine is x for those coordinates. So if I want to figure out sine of 5 pi over 4, or I'm sorry, 5 pi over 6. Remember, it's in quadrant 2, it's all the way over here, and it's going to use these coordinates, okay? Since cosine is x and sine is y, the y coordinate, it gives me square root of 3 divided by 2. To find cosine of 5 pi over 6, cosine is x, and x is negative in quadrant 2. So that gives me negative 1/2. And lastly, tangent. Tangent is a combo of the two. Tangent is actually represented as y divided by x. So the y coordinate is square root of 3 over 2 divided by negative 1/2. And we don't really like double-decker fractions. So I'm going to rewrite this. We're going to use keep, change, flip, or multiplying by the reciprocal. So this is actually the square root of 3 over 2 times negative 2 over 1, multiplied by the reciprocal. Doing this, we end up with negative square root of 3 over 1, or just the negative square root of 3. Awesome. Now that we've got this great review, let's talk about and introduce 3 more trig functions. You ready? Lego. Okay, so we already know sine, cosine, and tangent. So I'm going to introduce to you in just a second reciprocal trig functions, okay? It's just like Billy Mays always said, but wait, there's more. So what is the reciprocal? What's a reciprocal? If I'm going to introduce a reciprocal function, what is a reciprocal? So take a second and identify the reciprocal of 1/2, the reciprocal of 6/7, the reciprocal of pi over 4, and the reciprocal of 3. All right, the reciprocal just means to flip your fraction. So the reciprocal of 1/2 is 2 over 1, or just simply put 2. The reciprocal of 6/7 is going to give us 7 divided by 6. The reciprocal of pi over 4, it's a little weird, but we could do it. It would be 4 divided by pi. And lastly, the reciprocal of 3. Notice that 2 over 1 was the reciprocal of 1/2. So really 3 has a denominator of 1. The reciprocal of that then becomes 1/3. Awesome. So if that's what a reciprocal is, how might we define a reciprocal function, a reciprocal trig function at that? Let's check it out. So we've got these trig ratios, right? We've got SOHCAHTOA, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent, right? But we're talking about the unit circle here. Everything's been derived from that. So what is the hypotenuse always equal to in the unit circle? Or in other words, what is the radius of the unit circle? Exactly. The hypotenuse and the radius is 1. I knew you would remember. Perfect. It is 1. So we're going to use this to our advantage, all right? So reciprocal trig functions are going to have 3 new names, okay? So the reciprocal of sine, we're going to do the reciprocal of sine. We're going to flip our function, and we will end up with what is called cosecant. Cosecant, which is represented by CSC. Same thing, we're going to flip our trig ratio of cosine, take the reciprocal of it, and that will give us our next trig function, which is just called secant, S-E-C-A-N-T, or abbreviated secant, S-E-C. Right, and then same thing for tangent. We're going to take the reciprocal of tangent, and we will call that cotangent. So the reciprocal of sine is cosecant, the reciprocal of cosine is secant, the reciprocal of tangent is cotangent. Basically, these new functions are the alter egos of sine, cosine, and tangent, right? Or you can think of Bart and his evil twin, but they are just reciprocals. They are the same thing, just represented in a different way. So here's some values that we already worked through in the warm-up. Sine of 5 pi over 6 we found was 1/2. Cosine of 5 pi over 6, remember 5 pi over 6 is in quadrant 2, is negative root 3 over 2. And tangent of 5 pi over 6 is negative 1 over square root of 3. Evaluate the reciprocal trig functions based on what we know about reciprocals. So since sine and cosecant are reciprocals, sine and cosecant are reciprocals. If sine of 5 pi over 6 is 1/2, cosecant of 5 pi over 6 is going to be 2 over 1, the reciprocal. What is the reciprocal of cosine of 5 pi over 6? What is secant of 5 pi over 6? Yep, we're just going to apply the reciprocal. Cosine has the reciprocal function secant, so we end up with negative square root of 2 over, just kidding, negative 2 over the square root of 3. Now, we do kind of run into a problem here where we're going to need to do what is called rationalizing the denominator. So I'm going to take negative 2 divided by the square root of 3, and we have to get rid of that negative in the denominator. What we're going to do is multiply by root 3 over 3 to get rid of it. Negative 2 times the square root of 3 is negative 2 square root 3. And square root of 3 times the square root of 3 is a square root of 3 squared, or just 3. And that is our reciprocal. So secant of 5 pi over 6 is negative 2 square root of 3 divided by 3. Now you try tangent. If tangent of 5 pi over 6 is 1 over square root of 3, what is cotangent of 5 pi over 6? You betcha. We're going to just take the reciprocal, leaving us with the square root of 3 divided by 1 with a negative on the outside. So since tangent and cotangent are reciprocal functions, cotangent of 5 pi over 6 is negative square root of 3. Nice. So let's summarize. In order to find cosecant, you have to find what function and then do what with it. To find secant, you have to find what function and then do what with it. To find cotangent, you have to find what function and then do what with it. Okay, so to find cosecant, you have to find sine of x or sine of theta, and then take the reciprocal, aka flip it. What about secant? Yep, to find secant, you have to find cosine and then flip it. What about cotangent? Exactly. To find cotangent, we're going to find tangent and then flip it. Basically, we're living our best Missy Elliott lives. Let me work it. I put my thing down, flip it and reverse it. Exactly. So that is what we're doing with our brand new reciprocal functions. Okay, so how can we relate this and redefine our trig functions now that we have regular functions and reciprocal functions? So let's take it back to SOHCAHTOA, okay? Like I told you guys, it always just goes way back to SOHCAHTOA. It's our lifesaver. So for the unit circle, how do we define sine, right? Here's our little special right triangle over here on the right. Here's angle measure theta. If I was going to find sine of theta, remember we're going to use sine is opposite divided by the hypotenuse. So the opposite side of theta is y. The hypotenuse is always 1 in our unit circle. So sine of theta is y over 1. Now cosecant is its reciprocal. So using that, our cosecant function is going to be the reciprocal of y over 1. Cosecant is 1 over y. Now, if I was going to redefine cosecant in terms, since it's 1 divided by y, but sine is equal to y, cosecant is actually 1 divided by sine of theta. So that's a brand new way to define it. Now let's look at cosine, right? The ka. So ka, toa, the ka, adjacent over hypotenuse, right? Still for angle measure theta, adjacent side was x and the hypotenuse was still 1. So if cosine is x over 1, secant is going to be that reciprocal. Secant is going to be 1 over x. And if secant is defined as 1 over x, I can get a little crazy with it. Secant, secant of theta, if cosine is x, 1 over x is really 1 over cosine theta. And that kind of makes sense because if we think back to how we defined reciprocal functions, we said that cosecant and sine were reciprocal. So cosecant is defined as 1 over sine. Same thing, secant and cosine were reciprocal. So secant is 1 over cosine. What about the last one? Let's use the TOA part, right? Tangent is opposite over adjacent. Still from angle measure theta, opposite is going to be y over the adjacent side, which happens to be x from our special right triangle. So cotangent, being a reciprocal, is going to be the reciprocal of tangent, right? It's going to be x over y. And if we were to follow the same pattern, go ahead and make a guess. If cosecant is 1 over sine, and secant is 1 over cosine, how do you think we're going to redefine cotangent? Yep, we're going to define cotangent as 1 over tangent theta. Because they are reciprocals, it only is fitting that we can redefine them in terms of that reciprocal value as well. Okay, so pull out your best, Missy Elliott, put your thing down, flip it and reverse it. Another way to write our reciprocal functions, cosecant is 1 over sine, secant is 1 over cosine, and cotangent will be defined as 1 over tangent. Write this down, snap a pic. We are going to do some evaluating using all 6 trig functions, sine, cosine, tangent, cosecant, secant, cotangent. Ready? Buckle up, let's do it. So we're going to find all 6 trig ratios for each angle, and we're going to start with angle measure theta is equal to pi. Pi is one of our quadrantial angles. We know from the unit circle that this angle right here is 0 or 2 pi. This angle right here is pi over 2. This angle over here is pi. And the last guy down here is 3 pi over 2. So I want to see what is theta is equal to pi. So that means I'm going to focus in on this guy right here. What is the coordinate point of that? Well, x is -1 and y is 0. So since we have defined sine as being x, or sine is y, the y coordinate, sine is going to become 0. Cosine is the x coordinate, so cosine is -1, and tangent y over x is going to become 0 over 1, or just 0. So knowing that cosecant, secant, and cotangent are reciprocal functions, go ahead and define what is cosecant of theta, what is cosine of theta, and what is cotangent of theta. Remember, we defined cosecant as 1 over sine, so that's going to become 1 over 0. Are we allowed to divide by 0? No, this is actually undefined. Undefined. Secant is 1 over cosine, so 1 divided by -1, that gives us just -1. And cotangent is 1 over tangent, right? Tangent ended up being 0. So 1 over tangent, another undefined area. See if you can do the same for theta is equal to 3 pi over 2. What is sine of 3 pi over 2? Sine of 3 pi over 2. Well, before we do that, we're definitely going to need our coordinates. So 3 pi over 2, we're going to look at a different area of our graph now. 3 pi over 2 is down here. So we're looking at these points. Oops, that's a little bit of a shape. That's a shape there. And the coordinate of the value at 3 pi over 2 is x is 0 right there, but y is -1. So if we're going to define sine, remember sine is the y coordinate, so sine of theta is -1. And cosecant is 1 over sine. So that just gives us -1. Cosine of 3 pi over 2 is going to be 0 because cosine is y. And secant is defined as 1 over cosine. 1 divided by 0 is undefined. You can never, ever, ever divide by 0. Tangent is y over x, -1 divided by 0. That's undefined. We never divide by 0. And cotangent is defined as 1 divided by tangent, 1 divided by the undefined. Actually, so sorry about that. Tangent and cotangent. Cotangent is 1 over tangent, but it's undefined. That's a little weird. Remember, they're reciprocal. So I could just take the reciprocal of tangent, giving me 0 over -1, and that is just 0. So remember, we cannot divide by 0. It is not okay to divide by 0. Not okay to divide by 0, but what is okay, is if 0 is in the numerator, okay? We never, ever, 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 ever divide by 0. Crazy things happen. Remember back in rational functions, what happened when we divided by 0? We had holes in our graph. And then even further, we had asymptotes, right? We just can't divide by 0. The universe as we know it will literally fall apart, and it doesn't make sense to divide by 0. How can you divide by nothing? How can you take away nothing? We can't. We just don't do it. It's a sin. It's a, get it? A mathematical sin, not to be confused with sine, to divide by 0. Now that we're feeling pretty good about finding our 6 trig ratios, where would theta of -pi over 4 be? Find on this unit circle, which radian measure do you think is -pi over 4? Okay, so maybe you're not sure where to start, or maybe you're going, but let's just highlight where regular pi over 4 is, okay? So it's this angle right here. That is positive pi over 4. And I'm not interested in the positive though. I'm actually interested in negative pi over 4. So it's kind of a similar idea, except we're just going to go in the negative direction. Negative direction. So we're actually looking at 7 pi over 4, which means we're looking at these coordinates over here in quadrant 4. And since we have quadrant 4, it makes it really nice and easy for us to evaluate sine, cosecant, cosine, secant, tangent, and cotangent, right? Remember, for all of our coordinates on our unit circle, x comma y became cosine comma sine, right? Sine was the y value. So looking at 7 pi over 4 or our negative pi over 4 units, the y value is negative root 2 over 2. Now cosecant is 1 divided by sine, negative root 2 over 2, and that gets a little messy. Or you can remember that cosecant and sine are reciprocals. So we could apply the reciprocals. 2 goes in the numerator, negative square root of 2. Don't forget to rationalize. We end up with 2 square root of 2 over 2. And that reduces, don't forget the negative, to negative square root of 2. Cosine now is the x value. It's also square root of 2 over 2. So secant is 1 over cosine, or the reciprocal. We're going to have 2 divided by the square root of 2. We will need to rationalize, leaving us with 2 square root of 2 divided by 2. Those 2's are going to cancel out, leaving with just square root of 2. Lastly, tangent. Tangent is y over x. So we're going to have negative square root of 2 over 2 divided by itself, square root of 2 over 2. Anything divided by itself is technically 1. And we have that minus on the outside. So tangent is negative 1. Cotangent is 1 over tangent. And so that also gives us negative 1. Pretty cool, huh? So just to reiterate, a negative angle just changes the direction in which we revolve around the unit circle. Generally speaking, when we're working around the unit circle, we start here at 0 degrees and we work our way around counterclockwise. So that would be all of the positive angles that you see here. However, if we're talking about a negative angle ever, that just means we still start here, but we're going to go the opposite direction. It just changes the direction we go. So for example, if I wanted to go negative 30 degrees, that would be right here at 11 pi over 6. Or perhaps I wanted to go negative 120 degrees. So instead of going this way 120 degrees, I actually want to go negative 120 degrees. I would end up right here and I would use these coordinates to evaluate. If I wanted to do negative 180 degrees, I would go back 180 degrees, end up in the same exact place right here, but just depends on which direction we're going based on a negative. So a negative angle just goes clockwise. Positive angle goes counterclockwise. And lastly, I know you guys have been dying to use a little bit of calculator work because I've been seeing you in class wanting to reduce these fractions and things like that. So how do we find cosecant, secant, and cotangent with a calculator, right? Look at your calculator right now. Do you see a cosecant, secant, and cotangent button? Where are the buttons? Spoiler alert, there are none. So in order to do this, we're going to need to use 1 over sine, right? Cosecant is 1 over sine. It's the reciprocal of sine. So we're going to use the sine button to help us just determine cosecant. Same thing with secant. We're going to use cosine, 1 over cosine. Cotangent is 1 over tangent. So let's get into a few examples and wrap it up here. So evaluate the trig functions of cosecant of 65 degrees, secant of 112, cotangent of 360. I want you to first represent it in terms of the reciprocal, and then use your calculator to find that approximation. So for example, what I mean for cosecant of 65 degrees, that's 1 over sine of 65 degrees. And please make sure your calculator is in degree mode, not radians. And when we do that calculation, we just get 1.103377919. I'm going to round to 3 decimal places. So if we're going to do the same thing for secant, secant is defined as 1 over cosine. And then we just punch this in our calculators. 1 divided by cosine of 112 is negative 2.6694. Leave it rounded at negative 2.669. Cotangent is going to be defined as 1 over tangent of 360 degrees, which is a whole rotation. 1 divided by tangent of 360 degrees. And it says error. It's undefined because we're dividing by 0. We're dividing by 0, and we can't do that. Go ahead and find the values for secant, cotangent, and cosecant of all the values on the right in the same way. Use your calculator to round to 3 decimal places. Okay, secant of 227. Secant is the reciprocal of cosine, so it's really 1 over cosine of 227 degrees, and that gives us negative 1.466. Cotangent is 1 over tangent of 10 degrees, and that gives us a decimal approximation of 5.671. Lastly, cosecant is 1 divided by sine of negative 73 degrees. And this one's actually a little tricky because remember, negative 73 degrees means that we're going in this direction, starting here, and we're going negative 73 degrees. So to calculate this, negative 73 degrees is actually 1 over, to figure out how many degrees that is, 1 over, remember, a full rotation is 360 degrees. And we're doing sine of this. 360 minus 73. So that ends up being 1 over sine of 287 degrees. And plugging that in your calculator gives us negative 1.045. So since we were going in the negative direction, I needed to convert it to positive degree value. 360 degrees is 1 whole rotation minus my negative degrees will give me what I need. Awesome. So thank you for learning alongside here today. Take a moment to reflect and tell me, what are 3 things you learned today? What are 2 things that you found were quite interesting? And what is 1 question that you still have? Thank you so much. Have a great day, guys. See ya in the next class. Bye.